Hi everyone, this is a quick video that shows an easy way to diagnose assembly constraints and connection problems in SimSolid. Okay, one very common problem with assemblies in general is trying to understand if there's any movement that's possible, like a mechanism or something like that. Make sure your model's properly constrained. So always an exercise with static, linear or nonlinear analysis is to remove any rigid body motion from the model. So what is rigid body motion? Well, rigid body motion is simply any translation or rotation of the body does not cause any deformation. So, we have to get that out before in most cases, if you do inertial relief, that's an exception, but we won't go through that today. And remember, these rigid motions are in general for bodies are 6 motions, 3 that are translational, X and Y and Z directions, and 3 rotations around those axes. Also, as I mentioned, that these rigid motions, and this is the more subtle ones, they can come from movement between parts. So although the assembly is connected to ground adequately, you can still have this mechanism that are sometimes very difficult to visualize. And I think that's where this new rigid body motion capability that SimSolid has helps. Okay, so how do I diagnose it? Well, the easiest way is just run your static analysis and see if it fails. While that's possible, maybe a little bit better idea is to first run a modal analysis, either constrained or free, and kind of see if that shows any mechanisms. But the easiest way in SimSolid is just run this new SimSolid check rigid motions tool. The way you get it is you just pick this simple check button right on the structural analysis toolbar, and it'll do a very quick analysis and tell you if you have any rigid motions in your body. Okay, let's take a look at how this check rigid motions tool works. Let's first take a very simple model and let's insufficiently constrain it. So I'm going to take this model and I'm just going to pick a single vertex. So I'll just pick that point right there. Maybe I'll add a load here, but we're not going to use that. And I could try to analyze this. But before I do, let's do the check rigid motions right here. If I pick that, it'll look at the model and it says it's not sufficiently constrained. You have 3 rigid motions found. Do you want to see those motions? You say yes. And it'll give you the 3 motions it found here and then the standard legend for doing, deformation animation. So what I can do is I can look at the deformed shape and I can animate it. So you can see that I'm only picking that single point and I'm rotating about that point there. That's my first rigid motion found. If I pick here, I have a second, and pick here, I have a third. Okay, let's try something a little bit different. Let's get out of there. Let's go back and delete that immovable. But this time let's add a hinge, and let's just pick a hinge here. And just for kicks, let's pick a hinge there. And now let's check that. That's also not sufficiently constrained, but it only has 1 rigid motion. So if I pick there, it'll say, here's my deformed shape, and you can see that it's pivoting about those hinges. Okay, so if I really want to get this so it doesn't, if it doesn't have any rigid body motions, what maybe I can do, and let's just go back here and maybe add a sliding surface in the back. And now we can run it one more time. And this says now, everything's fine, it's sufficiently constrained, we're good to go, and I can just go back and run my analysis. And there we go. So maybe look at the display shapes and or the deformations, etc. Okay, here's one more example. This is a very small assembly, but we can look at how mechanisms get developed and how you eliminate them. So first, let's look at, I have 1, 2, 3 parts. I have pins at these 2 places here, and it's all bonded. So there's my model. There's a close-up of my connections, so you can see what I have there. And I've run it the first time, everything bonded, and I get, displacements as you'd expect, like that. Nice bonded pins at the end, and stresses like that. So let's look at it one more time, but let's go back in my second structural analysis here. I've made a few changes. So first, I've released these bonded connections, so I only have bonded to hold the pin in place, but there's sliding in there. So we have a mechanism we put in there. And also I've removed one of the hinges, so I only have a hinge at this end. So let's go and try this one and look at our check rigid motions tool, see what it comes up with. Okay, it says we're not sufficiently constrained, 2 rigid body motions found. It'll give us the opportunity to look at them. Again, just animate them. You can see one, we just have this falling here. It just, the whole thing is as you'd expect. But the second one is the mechanism that you see because, we have the sliding in that joint. So it's very easy to see both of those. Maybe just to play around a little bit, let's go back and add that hinge back. I can do that. Just pick here and do that. And let's go and check the rigid motions again. Now you see I've added it back. I only have 1 rigid motion, and again, I can visualize that very quickly. It's the rigid motion in the joint. So there you go, a very quick and easy way to look at your model and get rid of any mechanism or rigid motion. Okay, that's all I got. Thanks for watching.